There is a general trend in the ionization energy for the elements. As you go across the periods, as shown here, so lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. As you go across the periodic table from left to right, the ionization energy increases. As you go down the periodic table, helium, neon, argon, krypton, xenon, it becomes easier to remove an electron. So the general trend for ionization energy, for the first ionization energy for atoms, is as you go up the periodic table, there's an increase in ionization energy. And as you go from left to right, there's an increase in ionization energy. And that's shown here. The next idea is known as electron affinity. Electron affinity is the energy change that occurs when an electron is gained by a gaseous atom to form a -1 ion. For Cl gas to form Cl- gas, the following equation represents that. Cl gas adds 1 electron to form Cl- gas. The electron affinity for this is a negative value, negative 349 kilojoules per mole. Now, electron affinity for the main group elements is what we'll focus on. Notice that the electron affinity increases generally as you go up the periodic table, and also increases as you go from left to right across the periodic table, generally. There are two areas that I can see that may be quite different than the rest of the trends you see in electron affinity. The two that I have circled here. Positive electron affinities means that gaining an electron is unfavorable for these atoms. I want you to think about the electron configuration of beryllium and magnesium and all of the noble gases. Why would it be unfavorable for an electron to be added to any of these atoms? Answer that yourself. The final concept that we will be working on that's a periodic trend is electronegativity. This idea was defined by Linus Pauling, and by definition it's the ability of an atom to attract electrons in a bond towards itself. Electronegativity is based upon a relative scale. It can be measured only in relationship to the electronegativity of other elements, and one element has to have a maximum value of electronegativity. That would be fluorine, and it has a value of 4.0. Unlike the other periodic trends, electronegativity is unitless. The trend in electronegativity is very similar to that of ionization energy. As you go up the periodic table, you have an increase in electronegativity. And as you go from left to right across the periodic table, there's an increase in electronegativity. Based upon the same rationale for explaining ionization energy, you should be able to explain the trends in electronegativity.